is the introduction of power plant. Energy is stated as one of the most crucial matters for society, environment, resources, and even for international relations. Limited energy resources have major effects on mechanism of decision making. Use of fossil fuels has the dominating effect of all mentioned parameters on human being, specifically for environment. Thus, nuclear energy is one of the most promising energy supply sources with mature technologies at very large range of capacities. Nuclear energy is converted into thermal energy within a fission reaction and to mechanical energy with conversion units such as steam Rankine cycle. Nuclear power plant efficiencies vary from 30 to 40% depending on technology used, and these plants generate 16% of global electricity demand. So there is a basic principle of power plant. So in power plant we have four important components, which is boiler, turbine, condenser, and feed water pump. The function of boiler is to heat the water to produce steam. Then turbine will convert steam's thermal energy into mechanical work. Condenser will condense the exhaust steam from the turbine back into water. Lastly, feed water pump will pump the condensed water back to the boiler at high pressure. Other than important components, we also consider the efficiency of power plants. There is three consideration, which is thermal efficiency, means higher boiler temperature and pressure, and lower condenser temperature leads to higher efficiency. Then superheating and reheating. Heating the steam beyond its boiling point and reheating steam after partial expansion of also can improve efficiency. Lastly, regeneration, which is using heaters to preheat the water before it enters the boilers, can also increase cycle efficiency. Thank you.
Okay, now we go to schematic drawing. Okay, this is schematic drawing of nuclear power plant. As you can see, this is very complex schematic drawing because it has three different type of cycle. Okay, for the first part is nuclear steam Rankine cycle, and for the second part is MGCS cycle, and the third part is liquefaction cycle. Here I only focus to the nuclear steam Rankine cycle. This is nuclear Rankine cycle and basic Rankine cycle. Okay, basic Rankine cycle has pump, boiler, condenser and turbine. Okay, for the nuclear Rankine cycle has Chandu supercritical water reactor, turbine, condenser and feed water heater. Okay, Chandu SCWR used in nuclear Rankine cycle because it has a boiler, because Chandu SCWR as the main resource heat provider to NGCL. Okay, we can see the flow in schematic drawing. Okay, from Chandu SCWR, it flow to the first turbine and re-enter to Chandu SCWR and flow to the second turbine. From second turbine, it flow to the condenser and go to feed water heater and regeneration and go to Chandu SCWR. Okay, this is the cycle of nuclear Rankine cycle. Okay, nuclear Rankine cycle use reheat and regeneration type of Rankine cycle because it use two turbine and feed water heater and regeneration.
Now I will present about method of performance analysis. First, we go to comparison of energy and exergy efficiency. Energy and exergy efficiency of this cycle correspond to 41.7% and 50.6%. For the full HL capture, we get the energy and exergy efficiency value are 43.7% and 53.66%. So from this graph also, we can see when full HL capture for this nuclear power plant, it will get more higher energy and exergy than no HCl capture. And also, when energy supply subunit to this cycle are taken into account, less power requirement is expected to bring a more feasible integrated system in terms of performance. Next, this is the result of Linde-Hobson hydrogen liquefaction plant. And next, this is the TS diagram of Linde-Hobson hydrogen liquefaction plant. So, Linde-Hepson type hydrogen liquefaction plant is considered as the hydrogen storage subunit of the proposed system. Second, an isothermal compression of hydrogen is made and individual heat exchanger are internally utilized to cool down the high pressure hydrogen down to its critical points. And last one, liquid nitrogen is used to decrease the temperature down to 50 Kelvin, where an expansion valve is used to liquefy hydrogen at 23 Kelvin. Next, this is the result for steam Rankine cycle subsystem, and this is the S diagram of the SRC plant, which is steam Rankine cycle plant. So what we get from this graph is higher performance result than that of conventional SRC plant with reheating and regeneration. So this TS diagram that we can call back from our lecture. This is the Rankine cycle that we have learned before, which is we focus about reheating and regeneration. And then the net power output is set to a constant number, which is sum of power requirement of MGCL and liquefaction cycle, and the mass flow rate of the system is calculated based on this constant number. So what the difference from this TS diagram about nuclear power plant then that we learn from our lecture, that this is more complex TS diagram than our lecture TS diagram. So this is from this TS diagram for the nuclear power plant. We can see from the graph that have nuclear heat in, which is at higher of the graph, and also condensation at lower from the graph. This is the different from our lecture, our steam Rankine cycle that we have learned. This is the graph that we have learned at the class, which is simple from the complex TS diagram. So that's all from method of performance analysis. We move to next part.
Hello guys, we're gonna talk about the performance of the calculation of the nuclear power plant system. We can see the video clip about the nuclear power plant. There are three thermodynamic cycles inside one plant, which is a steam Rankine cycle, Linde-Hepson cycle, and magnesium chloride cycle. There are some calculations that we need to know, starting with the basic formula of the efficiency, which is Rankine, Linde-Hepson, and magnesium chloride cycle. Our journal focusing on the combination of the three main cycles of the entire system, starting from the efficiency of the energy and also the efficiency of the exergy. Overall efficiency show that the total useful output divided by the total input of the whole cycle. How we calculate the energy efficiency? First, we find the output and input of the entire cycle, then we use the energy efficiency formula to get the answer, like in the slide. Then to find the exergy efficiency, we find the basic information of the input and output of the exergy, and we insert into the exergy efficiency formula to find the overall exergy efficiency. We can conclude that the efficiency of the nuclear steam are very important to optimize the output power of the system. First one is optimization, improve system design and operation. Second, environmental impact, to reduce pollution. Third, economic viability, to get high profit. And last one is system reliability, lower maintenance costs.
The suggestion of system improvement. Firstly, we have enchanted thermodynamic such as detailed component model. By using complex fluid dynamic and heat transfer model, create detailed model for system components such as equefaction unit. Next, we have advanced equation of state, or we call EOS. Under different situation, predict the thermophysical characteristic of hydrogen and helium with accuracy by using precise EOS. Next, we have integration of advanced control strategy. Firstly, model predictive control or MPC take into account future events to improve stability and efficiency by optimizing system improvement in real time using MPC. Next, we have artificial intelligence, or we call AI, to forecast system behavior, optimize process parameter, and manage intricate subsystem interconnection. Lastly, we have multi-objective optimization, economic and environmental trade-off.